So today we will discuss about Apache HBase. So HBase stands for Hadoop database. So this is different from Hive and any other databases. So we call this as a NoSQL database, NoSQL. So NO means like not only. So not only SQL database, and the storage format, it deals with columnar. So with that, it provides faster random access and write also. So you can read write efficiently comparative to other databases. Okay. So now I'll just show you how to launch or how to work with this. Then I'll go through slides. Okay. First, if I explain it to you, then it will be easy for you to grasp the slides. Okay. So to launch HBase, again, same way, you can go to terminal, and then we have seen, like, if you want to enter Hive client mode, we have typed Hive and then pig. That's all. So it went to automatic map reduce mode, and then we coded something like loading the data and reading the data, everything. So now to work with HBase, you have to type HBase and then shell. Okay, HBase hyphen shell. Yeah, now you see you are in HBase interactive shell. Okay, so to create a table, we will just create a sample table, and then what is the style of inserting the data and retrieving the data, we will see first a few commands, and then we'll go through slides. Okay, so if you want to create a table, it's not a create table name kind of a regular syntax. It is, let me open HBase practice. So here, this is something only, it is not that complex. So if you want to create a table, you see the syntax, this is the one. Create, then followed by the name of the table. Then this address and batch is something that, column family. So unlike we have a regular table and then rows and columns, we will have column families in HBase. So column families are something that it's group of columns, that's all. So unlike we have a regular columns and then regular rows, we will just maintain column families in order to have a faster access. For what we will see later. So for now, let's create a table with two column families. For example, you have a student ID, name, and age. Okay, then you are maintaining address and his related, like information, address or his details about marks, something like that. So you can split it. Now when you have a five columns, you can split three into one column family and then two into one column family, like that. So that's what I'm doing it here. So create student, address, and then batch. But you see here, HBase is schemaless. I'm not defining that that particular address is having two columns, for example, state and city, and batch is having some other column. I'm specifying you only column names on, sorry, column family name, not actual columns. So let's create first the table. So this is the syntax to create the table. Create student, address, batch. Okay, it says that, I think, create table is already available. One second. Table already exists. So to drop a table in, okay, to drop a table in HBase, you need to use drop and then student. But this will not work. Let me see. Now you see here, drop the name table. Table must first be disabled. So we have to first disable the table, then only we drop the table. Okay, so disable. of the table. Now let's create the table with the name student. Okay, create student address and table has been created. Now if you want to see the description of this particular table, you can just type this. You see here column family description. So column family is name, address is the one of the column family, and name, another one, batch is the one of the column family. So we talk about cells also, guys. Cell is nothing but where the particular data value resides, that is called cell. Okay, we will see how to insert the data, and then we verify how to check the cell in the particular table. So now if you want to list out, now created the table, now if you want to list the table, just list, that's all. Now you see I have multiple tables. Just now I created student. There are other tables also. Yeah, so to list out all your tables, you type list command. Okay, now let me insert one record. So to insert a record, okay, put command we will use. Put, then followed by the name of the table, then name of this person, and then address city, and then particular city name. So if you see here in the table, what I have given, create student address and then batch, right? So now I'm loading this data using put command. Okay, one second, let me copy this. So when you are inserting the data, put table name. This particular after table name which comes here, this is a row key. Key means, so every table will have a row key. So along with column families, row key. So row key is something that it is a unique to that particular table. So in HBase, we will call tables as a regions. Okay, region. So regions are served by region servers. So for each particular region, one region server is available. So region server, what it will do, it manages the data. So it manages the information. So whenever clients tries to write, when he tries to write some data, so it understands that, and it gets that data, and then it will place into some region. For example, if the region is full, like it will have a limitation. So if the table is too large, it will split into half of into multiple regions. Say for example, a table region A is full already. The data is filled up, and then when we are trying to load furthermore, then what will happen? This particular server, region server, handles this and then split it into two halves, equal halves. So if you have some 100K records, so 50K records will be written into one region, and then 50K records into other region. So that's how it works. So for now, you see here, I'm trying to insert the data. So when I'm inserting the data, put and then student, this is the next one is the key, row key, and then you see here address colon city. I didn't mention anything here. When I'm creating the table, I'm not specifying any city or state, any other value, any other column. So I just mentioned the column family. So when you are inserting the data, you can dynamically specify that address colon city, and then this is the value. This is actual value. So you understand, guys? Any doubt?
Yes, Raja.
Yes, please.
So, address is the family name. So,
Yes,
colon city. What is the city thing doing
that is the
over
column.
there?
So that is the column I'm giving.
Okay, so okay, under one column family, you can have multiple
Yes,
columns, right?
yes. Now I'll show you. Now I'm inserting city. See, city is
Okay,
I didn't define anywhere, but while I'm inserting the data, I'm specifying that. So that's what schema free. So HBase is schema.
okay. And also the row key, you said row key
Yeah,
is the unique value for a table. So,
exactly,
does it exist throughout other column families also? Like
exactly,
it will have
exactly.
the
No, with other columns. So let's see. Let me insert this. If that address is not a duplicate, then it will not take. Okay. So let me execute this statement and then show you the table. So to show the table, to visualize the data, you have to use scan and then Okay, scan and then student. Now row is John. Okay, for John it is, see, the display also is something different. You see here, column plus cell. So column is address colon city and then timestamp. It will have a timestamp, guys. For every insertion, it will maintain timestamp. So which is useful to retrieve the records also. Okay. So now if you see here, column is address and then city. The value here is Albany. So HBase stores the information in terms of key and value. So that we will see here. 1 second. Let me go to, yeah. Now if you see here, HBase, now wide column store. So stores data together as columns instead of rows. That's what. This is useful for optimization. When you have a large data, it is useful. So it will store the data in columns. That's what NoSQL type. Okay. Let me complete this and then come to this particular slides. Okay. Now you understand here. So we are just inserting the data like this. So specifying column family, then followed by colon, some column name, and then this is the value. So let me put the other value. This is state. Now you see, I mentioned same. Okay. Now put student, name of the key. This is the key row, and then address colon state I'm giving now. So here I had given city, now state. Let's see. Okay, enter. So now I'll scan the table. Now you see here John, but it is one row only. It's still one row only. It's not two rows. So John, and then you see column address city state, and then timestamp it created, and then values. Got it?
Yes, Raja.
How
So
about
for
that?
other person,
Yeah, yeah.
so if we have another person,
If you have
so
another,
we create another row with a new
exactly.
row.
Now we will go ahead with stream.
Yeah,
So
making some sense.
yeah, now let me create, because we have batch also. Let me create this and then scan the table again. Now you see here, so for join, we have three values. Okay, one is city, state, and then stream. So now let me insert records for other guy. So this is other guy.
Can't we enter at the same time? I mean, you are doing insertion for city ones, state ones, and
Yeah,
batch
yeah, yeah.
ones. Can we
Yeah, yeah. Yeah,
write it?
we can do, Kalpana. So we have an option to upload the data from HDFS to HBase. So we will do that. So remember guys, so the data which we are loading here, end of the day, it uses H files called H files, and those H files will be again written into HDFS path. So that we will see later. So now if you,
No, what I'm asking is here when you're putting the new row, so we can write address, city, state, everything in a single line, right? We
okay,
can't.
okay. No. When you are inserting the data, this is how you will insert the data. Put command.
Yeah, we put student, Paul, address, city. You have given the value, comma, address, state. We can't give it like that in
Let's
a single
try.
statement.
Demonstration purpose, just I was inserting one each line. Let me try.
So there is a comma missed.
Put, you have to specify either of the syntax. So it says that add arguments. Okay. Hmm. Okay. So it is returning error. So we have to maintain key value attribute. Okay, put R1C1 value TS1. I think it is not understanding, Kalpana. But let me try.
Okay.
So for now, let me just insert the data. Then I will insert the other row. Now, if you scan the table, now, for example, if you try to have a same record, like you are asking, right, Charan, like how if the same person is having the other record, when we try to insert the same person with some other record, what will happen? You see here, I'm using this record, Paul, then batch stream. I'm trying to insert .NET because I'm going to change this Java. So whether it will create a new record or else it will update it. So let's see. See? So that's why row key is unique.
Okay, makes sense.
Yeah, it's
And
not.
yeah, that's it. No, it makes sense for now.
So now this is how you will scan. So if you want to get a specific record, so this is how you will see. You want to see only related to John, the data. So you have to use get command. So get student, this is a table name, and then which is the key. So this is the key John I'm using to display the data. Only to that particular record will be displayed. Okay. Is
So there is no specific data type or size of the column, nothing. So
nothing,
we can.
nothing. Yeah, that's what it's a kind of NoSQL. So NoSQL will really not follow any schema, any data type. So that is advantage. So now we will discuss about this one. You're asking same thing. So what will happen? Yeah. Yes. So OLTP. So OLTP, like online transaction processing. So your net banking or debit card transaction, credit card transaction, or some other activities all comes under OLAP related applications. So they will try to insert the data as soon as that transactions completed. We will try to get the data and then load it to somewhere. So it's a kind of a transactional data. And sometime if you want to analyze the data, because if you take some Visa card or any MasterCard, they will do almost per second 63,000 transactions per second. So in this case, if you want to really load the data and then you want to process it for some reason, because once you load the data, sometimes you may request for generating some report. So what was my transactions between so and so period? So to deal this one, and if you store in RDBMS, this is not a right choice. And even for OLAP also, OLAP is something that again analyzing the historical data. So these two cases, one second guys. Yeah, so these two cases, RDBMS will not be sufficient to process it. So that's why we move to big data. So that is what Hadoop, right? So just recalling. So now, earlier when there was no Hadoop distributed file system, when there was no Hadoop, so what was this Google was doing? Because Google was serving from that period itself, like 95, 2000 itself. So they were using Google file system. So in 2003, they released one white paper also, and it is based on distributed file system. Same thing, like you can distribute it, and then they can process using MapReduce. So MapReduce and file system, I mean distributed file system, they introduced in 2003 itself. Okay. Now what they will do, they will just process in chunks. So they'll process in chunks, and then they split the, I mean like they split the file into chunks, and then they'll start processing, and they will maintain each chunk server in order to process files and then serve back to the client. So that was the concept. So now later we introduced Hadoop, so which is extension to that particular Google file system, and then MapReduce. So now Hadoop is used to store terabytes of data or petabytes of data. But the problem here is, again, limitations are, we can process the data in a batch mode only, because it's not real time. It's not even near real time. You cannot perform real-time operations, and you cannot have a random access to the Hadoop. So that was the limitation. And even low latency queries for Hadoop, it became a bad choice. So that was the limitation. So now NoSQL. So NoSQL is something, but not only SQL. So era started. So these are the 4 types that we had. So document based, column based, key value, graph based. So document based is something that, so they will store a record not in a regular fashion. So they will store it entire record in a kind of a document. So document is something that entire record you will put into one cell. And column based, this column based also equivalent. So key value, so just now we have seen, but it is not actual key value. So key value is something that, again, you are not maintaining the entire record like a rows and columns, you maintain key value pair kind of thing, the data. And then graph based, so you can also have an option to store the information in terms of graphs. So those tools are available, we'll see in the next slide. So why this NoSQL? Or, for scalability, availability, and high efficiency write and read. So this is the main purpose. Read write will be like an efficient comparatively other RDBMS, because it will follow kind of a key value, whatever the features that we have seen. With that, it will have a high availability. I mean, business application wherever it required, so NoSQL are perfectly suited. This is the advantage of NoSQL. So these are all advantages. So what you can see, mostly open source, one thing, low latency and continuous uptime and globalization and global distribution. And other one is it deals with the structured, semi-structured, and unstructured data. Read write anywhere, read write, and supports large volume of the data. So these are advantages of NoSQL. So we are discussing HBase is one of NoSQL. So other types, these are all NoSQL database type available in market. Key value databases are React and Redis, and wide column stores Cassandra and HBase. So Cassandra and HBase are similar. So if you learn HBase, it is very easy to understand Cassandra also. That is also followed columnar storage format. And graph databases, for example, this is the one, Neo4j and Hyper GraphDB. This is a graph databases available. And document databases. So document database, that is only deals with MongoDB. So MongoDB stores the data in terms of actually JSON. Actually, the format is JSON, but you can refer it as a document-based database. So MongoDB. So now we come to HBase. So by analyzing the limitations of Google file system and MapReduce, whatever we have, so they introduce, actually, Google introduced one more concept called BigTable. So when nothing was there, I mean, no big data, Hadoop was there. So Google was maintaining one table called BigTable concept. Okay. So the concept of BigTable is, it will not only uses, I mean, it uses Google file system for data storage, as well as it will process the data in number, like small number of data files. So it will split the larger files into smaller files, and then it will start processing it. So which is an effective way to deal with larger files. So that's how HBase came into picture. So as per the Google's white paper, this is the definition. So BigTable is nothing but a distributed storage system. So for managing structured data, and which is like designed to scale to a very large. So you can just increase that distributed servers. You can add machines So petabytes of data across thousands commodity servers. So you can add servers as well to deal with your data. Applications, these are all the applications that we see: time series data, marketing data, financial data, and internet of things data, graph data. So this is where it helps to deal with big table areas. So Hadoop database, so HBase refers to Hadoop database, and it is an open source, and it is the implementation of Google's big table. Okay guys, so now HBase, if you see here, HBase is again like a set of tables only. So for each table, you will have a traditional database contains rows and columns, and which is part of Hadoop ecosystem end of the day, to just deal with real-time read and write access to files in a HDFS. So end of the day, HBase also works on top of HDFS. So it will enables the real-time read and write. This is the one of the advantage. Okay.
So HBase is like something like Hive. Can I say that?
Exactly. Hive. It is like a Hive only, same database tool
So
only.
what's the difference here?
That's
Like
what.
I
But this,
understand. Oh, Hive is
yeah,
only structured.
correct. It is semi-structured and structured, and the way it deals with display the data, everything is like different. I'll have one more slide where I can differentiate those two. Let's see.
Okay.
It is designed to store semi-structured and both structured data. The other one is HBase has a horizontal scaling ability. So horizontal scaling ability is something that if you are able to add machines to your existing cluster, that is horizontal scaling ability. Vertical scaling ability is something that if you add memory, CPU, RAM, like that, so that is vertical scalability. So HBase supports horizontal scaling. So now HBase and RDBMS. First, we'll see the difference between HBase and traditional RDBMS. So column oriented and then row oriented. So flexible schema. So you can add columns on the fly. So RDBMS fixed schema. So before you are going to create any table, you have to specify the schema. Okay, so for good with sparse table, not optimized for sparse table. So sparse table is something that they will use some algorithm to improve the read access. So they will store the data in terms of like they will sort the data and then they maintain some ranges. And when you specifically retrieve, when you try to retrieve the data from those tables, the retrieveness, faster, it will be faster. So it will support, HBase supports sparse tables, whereas RDM is not optimized for sparse tables. Okay. And we have a MR concept. So MR works on HBase. Of course, you cannot work with RDBMS MapReduce concept. That is what. So horizontally scalable. That's what I told. Like you can add machines, n number of machines to your existing cluster. So hard to scale. You cannot increase the like machines for your RDBMS. First of all, it's not distributed itself, and so it can handle semi-structured, unstructured, but RDBMS cannot. Okay, this is basic differences between RDBMS and HBase. Now we will see Hive and HBase. So Hive is a kind of a ETL tool. So whereas HBase is NoSQL. So NoSQL means like not only SQL database. So both can run on top of Hadoop. That is okay. And you can have multiple operations like join, group by, and filter here, but it will be limited. HBase has limited, only insert and delete operations can do, because it is like to deal with larger sets. So you are not going to use any joins or group by and any other filter also. Okay? So that's how filter, basic filter, like which record just now we retrieved record for only John with the student name John. So that's how you can apply some filters. And Hive is suitable where query time is not important like ETL. And whereas HBase can be used where query time is important like website. So to perform a faster queries or to have a faster access to the data, so we will use HBase. If you see small comparison they have given, so comparing HBase and Hive is like a comparing Google and Facebook. Even though they compete over the same field, but both provides different functionalities. That's what. Okay. So Hive is a SQL engine which runs on MapReduce, whereas HBase is a NoSQL key value database. So here components that we need to remember, like HBase in the HBase, there are three major components. One is HMaster, Zookeeper, and then region server. So these three components will work together in order to improve the performance of that particular HBase. Okay, HMaster, Zookeeper, region server. We will see how they will work. HMaster, Zookeeper, and then region server. So I told region server already. So regions are nothing but tables. So each region is associated with one region server. So region server responsibility is to manage and distribute the data among regions. Okay, Zookeeper is something that again it's a lightweight server actually. So it deals with what regions are region servers are available, what client is requesting. So it Zookeeper is something that it organizes and configure the servers. Okay, so that we will not really see the advantage, but yes, Zookeeper will be running behind. Okay, let's see. So now HMaster is something, this is the components that we will have. H region server, H region. So H region is again table. So table will be having a memstore file and HLog. HLog also log file will be available for each region server. We will see in next slides about key components of HBase architecture. So HMaster, so this is responsible for performing the administration. Another one is region server, so which is responsible for managing and hosting regions. So H region, it is for a table and it's a basic element availability and distribution. So HLog is something that it will store updates regarding HBase table. So HLog will be having all the information related to your table. Say for example, you are writing one record, so it will capture that particular information. So the record has been loaded at particular time, like that. So HLog. So these are all basic components in HBase. So data storage in HBase, how the data has been stored. So unlike relational databases, like where we store the data in tables, and these tables same like regions in HBase. So we refer to terms tables in RDBMS, but we will refer to regions in HBase. So what will happen? So when the table size becomes too large, so the table itself like partition into multiple regions. That is the concept of HBase. That to equal size of records. Okay, guys. So it is roughly the same when it is splitting the regions and it will assign to a different server. So the server region server is roughly the same. Okay, when it is distributing a number of regions hosted by each region server is roughly the same. We will see in the next slide about this splitting. HBase component, yes, we have seen HMaster. So HMaster responsibilities are these one, like perform administration, monitor and managing the cluster. So what does it mean, like monitor and manage the cluster? Sometimes if a node fails, if a cluster if a cluster is facing some issue, so it will monitor and then manages. It informs to the server, and then it will also assign regions to the region server, like tables to each particular table server. Say for example, if a region server is running with high load, and if it is able to identify any another region server which is having bandwidth, so it will just split that particular regions to the other server. So like it will manages the load balancing. So it will also controls the failover. This is HMaster. So H region server, these are all the responsibilities of H region server. So also it manages automatic splitting. So not only managing and hosting of regions, so it will see splitting of regions and read write request, handling read write request. 1 second, guys, it's showing us less than a minute. I'll just stop it and then we'll connect back. Okay, immediately I'll join back.
Sure.